how the world doesn't appreciate enough these beautiful round parentheses that can be so much. But it seems paradoxical that even though the world is having trouble accepting these round parentheses, for some reason they get really excited these days about sharp parentheses. Okay, so the parentheses that look like this in HTML are suddenly getting everybody in the world excited. Okay, now this seems rather silly, but it gives us a sort of opportunity. Maybe if we change the shape, change the shape of our parentheses, okay? Think about how to do what we do in Lisp, but somehow do it with these sharp parentheses that people seem to like so much better. Maybe we could get some of the Lisp ideas more accepted, okay? So round parens bad, sharp parens good. Okay. So I think that even though, again, all of us are sort of disappointed that the world isn't picking up on Lisp as much as we think they should, I think the state that we're in now is that we have, I think, a unique opportunity, or we have actually several unique opportunities. And I think what's happening is because of all the web phenomena, and because people are starting to program the web so much, that some of the Lisp ideas are actually very, very timely for the current needs of people programming the web, but we just have to explain it to them in ways in which the web community can understand. So, and I think the big opportunity that we have is the web community, programming community basically blew it. They tried to make ways of programming the web, and the result is a terrible mess. Okay, so we can be the white knights and come in and fix it if we play our cards right. At least that's the strategy, that's the opportunity, I think. And so, even though they're reluctant to accept the round parentheses, the sharp parentheses that you find in HTML, and by extension, XML, those, I think, can be the basis for communicating some Lisp ideas. So the idea is basically to turn XML into what they call SX expressions. Okay, so we're just going to have the parentheses, and the only difference is that you have to put the names on both sides of the parentheses. But basically, the idea of having a uniform representation for data, XML is really a uniform representation for data. Okay. And at least that seems to be the least common denominator. The one thing that the web community can agree on is XML. Okay, so we're going to take XML and we're going to make it into a programming language. Okay, the only problem is XML is static data. It's not very good at dynamic data that we have in Lisp, and it's not very good at doing code. So somehow we've got to fix those problems. Okay, so here's just a quick overview of the web programming world. Okay, and in fact, it's running off the right side of my browser here. But just, and this is by no means complete, but these are just a few of the formalisms that are involved in web programming these days. Now, I don't know how many of you really have experience of doing, large distributed web applications and all that stuff on large scale, but that it's not unusual for even a fairly mundane web application to have 6 or 7 languages in it. Okay, if you go to the web homepage, in the Web Consortium homepage, you'll find 19 different languages that are linked off the top level of the homepage. Okay, so how are people going to learn all these languages? How are they going to write applications with all these languages? And the worst thing is that even if you could learn all the applications and write all the programs, how are you going to debug it if something goes wrong? Okay, if something goes wrong in my program, how am I going to tell whether the problem is in the JavaScript, the Java, the JavaScript, the PHP it's running on the server, the Perl scripts, and so forth? There's really no unified integrated environment for all this stuff. And it's driving people nuts. Okay, so we talked at this conference about it's hard for people to find Lisp programmers. It's getting hard for people with web applications. They'll list 7 different languages that you have to know to run an application. It's hard to find particular people who know all the combinations of the 7 different languages. And I've been in a lot of meetings about the web community, And I keep asking them, how are people going to learn all this stuff? And I haven't gotten any good answer. Okay. So, and why, first of all, why are all these things necessary? Why do you have to have all these different languages? And it usually turns out that somebody made a special language. Well, first of all, HTML was coming out of XML, so it wasn't designed to do what it's being asked to do. And then every time somebody needs a new capability, like web services or separating data from presentation, like style sheets do, then they invent some kind of half programming language. They invent some very specialized language. They get the layer on top of all the other languages, and later on they find out, well, gee, it would be great if you could program in this language too, and so they add a few programming constructs, but kind of not enough. And it's gotten to the point where Java, for example, you have Java, but then there's also Java server pages and JSP. And then the Java that runs in the Java service pages isn't quite the same Java as might run in your Java applet. Okay. And then another problem with all this stuff is that suppose you finally get down to the point of writing an application that sells pencils or something. Well, how many different data structures are you going to have that represents a pencil? So are you going to have a Java class for a pencil, an XML representation of a pencil? Your, all of these different layers and things are going to have their own representation of the data structures. There might have to be a different representation on the client and on the server. How are you going to keep them all consistent? Okay. So the web programming, it seems like the web programming world is just collapsing of its own weight. Don't get me started here. So I think I should stop talking about the problems and start talking a little bit about some of the solutions. Okay. But I really issue a challenge to the people in the web community that really nobody has come up with any kind of roadmap of really answering the question, how many languages do you need to program the web? Okay. So again, there's the fact that none of these are general purpose programming languages with extensible data structures. They have a redundant representation, and then debugging is the really, really important thing. Okay. Well, some of you might be asking, why don't we just program the web in Lisp, since it's certainly possible to write a web server in Lisp? And my answer to that is, actually, if you can, you should. Okay. And there are several solutions for basically being able to write Lisp programs that produce web pages or that do some kind of web programming. One that I like is John Mallory's very, very excellent CL HTTP, Common Lisp HTTP server, but it's really more than just a web server. It's really an entire web programming environment with HTML parsers and with a search engine implemented in Lisp and lots and lots of stuff. And so that is a viable web programming environment, I think. Franz Allegro Serve, we're also using Franz Allegro Serve in some of our projects, and I think that's perfectly fine. That gives you a way to program in Lisp. And there are others. There's a Lisp Web, which I believe comes out of Italy. There was a talk on a Lisp version of active server pages. So that's another way you can do it. So I think there are a lot of solutions for programming the web directly in Lisp, especially in the case where your application is just a web server, and as all anybody's going to see on the other side is just HTTP pages, and so they don't really care what your application is written in. Just like the Orbitz application we heard about can be written totally in Lisp because the customers don't care about what programming language is, and that's a way to avoid language bigotry. Okay. But you may wind up in a situation where you can't quite do that, and one of the reasons is you might want to interface with some stuff that's written in some other programming languages or some XML stuff. I think the biggest reason is that you might want to have to convince some of your Lispophobic colleagues, and they would like the sharper parentheses better. Okay. One of the goals also we had into that is you might want to put web code in web pages. Now you can already do this, for example, with JavaScript and with several other technologies, but of course, JavaScript is not the same as XML, so you might have to, and JavaScript is a very poor language for making data structures in. And JavaScript has nothing to do with Java. I don't know why they call it JavaScript. And so there are many reasons why the current ways, and there are a lot of limitations on where and under what conditions you can use JavaScript in your program. So JavaScript is really kind of a limited solution for putting code into web pages. And then finally, I think integrating programs with hypertext and multimedia web content. There's one way that, and so what that means is that Lisp has sort of, if you think about Lisp, it's really, a Lisp program is mostly program, and then there's just a little bit of data in it. Okay, so you might have strings or lists or literal data. But on the web, it's sort of the other way, is that you have a lot of, most of the web pages are sort of mostly data, they're mostly hypertext and pictures and so forth, and then you might want to have a little bit of programs in there. And for that, some of the water language, which I'll show you, has a bunch of advantages. Basically, it makes your web content be first-class objects, which it's not easy to do in a direct, in a traditional Lisp, although it could be managed. Okay, so we have the water programming. I'd like to introduce you to the water programming language. Basically, it makes a programming language out of XML simply by defining a programming XML tag for each programming construct. So there's a construct that says open angle bracket def object, and then close angle bracket, and so forth, and that's like having a Lisp-S expression that calls a function def object. Okay. And then we run an interpreter. The interpreter is currently written in Java, and it runs in the client browser or on a server. Okay. Okay. So it's really Lisp and XML clothing. So one of the hallmarks of Lisp, of course, is the read-about print loop. So the way you can think of it is the read-about print loop is an XML read, okay, followed by the water eval, and we'll talk about what that is. And then there's print, but in Lisp you just print strings, okay. But in water, the print returns a piece of HTML which you use the browser as a display and print it. Okay. So an XML read eval, and then eval is the read eval print loop. Okay. So and then the other thing is, we can by doing this we can do one of the hallmarks of Lisp, which is code is data, data is code. Okay. So the world has already decided that data is XML, so that means we have to make code XML, and you can't quite get that by programming in Lisp. Okay. And then all the other things like, for example, debugging. And one thing that I really, really like is having source code expression level stepping. Okay. But of course, we couldn't resist but it's not common Lisp. We couldn't resist the temptation to tinker around with the Lisp model a little bit. So we integrated function call and object creation. I'll talk about that, and we'll see that. Basically, if you have angle bracket foo, then that can either be a function call to foo, or it can be creating a foo object. If you have a piece of bold text with angle bracket b, then that's really creating a bold object, which has the content of the text as being a field of that bold object. So in water, we have arguments, which are just like arguments in Lisp, except in XML you only have keyword arguments. We have keyword arguments, positional arguments, and then we have a content argument, which is the HTML that's between the two bracketed expressions. Okay. And then hypertext multimedia is a first-class data type. So again, in Lisp you can only have strings. But in water, you can have strings that have pictures in them, strings that have movies in them, strings that have pointers in them, pointers being represented by URLs. So it's sort of enriching that string data type to represent everything you can represent in HTML. Okay. So what I'd like to do with the remaining time is give you just a tiny example of what the water code looks like, and show you, give you a little example and give you a little quickie tour of the water programming environment. So the little example here is very, very simple and short. It's just kind of the idea is that your server application puts up a subscription form, the user fills it out, then the user's name is added to some subscription list. Okay, that's it. Okay, so before we go into the demo stuff, I just want to remind you, you can check all this stuff out at waterline.org. The language itself is free, and it's free for non-commercial use. There is a small company, Clear Methods, which is trying to license commercial versions of this and tools surrounding language. On the website, you can just download the interpreter, so you just download the interpreter and it'll run as a Java applet. It should be platform independent. And then, and you can also on the site, there's a book that you can download. There's documentation, tutorial, basically everything you need to get started. And we'd love to have the feedback from the Lisp community to it. I would also like to, at some point, make an interface so that Common Lisp can interface directly with it. And by the way, this presentation is written in Water, so I'm not using PowerPoint, I'm just using the browser, and we're running Water code to do the presentation. So my first example will be the presentation. Okay, so can you guys see that? Is that big enough with the font? No? Okay, so here is so these are what produces the slides. So there's a function called slide, and it takes as arguments the title. Okay, so title is really only the only named argument to the function, or it's a positional argument to the function here, and then the remaining arguments are pieces of hypertext, which gives you the data for that. So just, sort of scroll through there. Okay. Now, one thing you might notice is, I told you this was XML. It's not quite XML because, for example, this is not, so here's, a little bit of hypertext where you have an image here. Now here, we didn't close the thing with a /slide here. Okay. So I lied a little bit. It isn't quite XML. One of the reasons we didn't make it quite XML is because XML is ridiculously verbose, if you've ever written it. Okay. And so we have this thing which we call concise XML, which is a slightly different syntax of an XML, and it's absolutely one-to-one with XML. You can use XML 1.0. And if you want to write full XML, you can. And also, we have the system spit out full XML 1.0. But most of the time, we for example, let you write a closing parenthesis without having to repeat the tag. Okay. And again, we do things like positional arguments and rest arguments, which are not allowed in XML. Okay. And actually, I took that. The object system is the prototype object system, so that's where it differs also from CLOS. Okay, so in some sense, Water is the most widely used programming language in the world, even though you haven't heard of it, because every HTML program is automatically a Water program. Okay. And here's sort of the code for the slide presentation program here. So, thing is the top level node of the object hierarchy. And so there's just, set slides style equals, and then there's, a bunch of HTML, XML stuff that just lots of parameters that set the slides. We made actually two styles, one for the interactive presentation and one to print handouts. And then again, the slide thing works for both of them. Okay. And now, so that's sort of what it looks like. And now, this is just a little piece of the programming environment, which is the inspector. Okay, so we can inspect the data structures, and I don't think I can make the font of the inspector bigger here. Let me see if I close this window. Well, all right, we'll just look at this. So, for example, so these are the parts. So this object is my talk, okay, represented as a Water object. It has a parent, which is so here the parent of this object is the object taught. So it's a prototype object system. Any object can be instantiated. There's no distinction between classes and instances. Okay, and then here are some fields of it: the audience, the content, the date, and the time. So if I get the date time, that's a date time object with month equals 10, year equals 2002. If I look at the content of it, then it's a bunch of fields, and in each field, the objects are, each slide. And then each slide has a content, and then these are the individual bullet points in the thing. Okay, so this is all not very unusual as far as list people are concerned. This is what you expect. This is what you want. This is what you have a right to have in your system. But we very, very rarely have it in web systems. Okay, so now I'm just going to show you another example, the subscription example. Okay, so here's the subscription example. So we defined an object called the subscriber, and the parts of the subscriber are the full name and the email. Okay, here's the list of all our subscribers, and it's an empty vector. Okay, then we make this. So this is sort of a global variable here. It's called subscription form. Okay, and then the action is subscribe. So here we have what looks like just an ordinary XML form. Okay, but what you need in the action part of the form, as far as HTML is concerned, is some URL that you're going to call on a server. Okay, and then typically, if you're going to do this program without something like water, what you have to do is then go and install something on a server which actually responds to the system. But here we can just put a piece. We're going to actually have it call a piece of code which is sitting in the very same file. Okay, so we can write code that's going to be, running in both places. Then the rest is that here's just the stuff for the HTML, and then we have a function called receipt, and it takes the name, and this is going to be the name that you typed in there, and the name, and then we just give you a little response to the page that says that that name is now subscribed. Do is actually eval, so this is eval, which we need in HTML because we need to have an explicit eval here because the default is treated as a piece of hypertext. Okay, and then we say that person is now subscribed, and then here's the top level call to subscribe. So here's how we subscribe a new person. So we say, take the list subscribers, then we call the method. So the syntax for calling the method here is you have the object, the dot notation, and then you have an XML to the call insert, which inserts something in a list, and then here to the call for subscriber, which puts out the form. So subscriber returns a value, so just like a list, and everything returns a value. Okay, and then we can just insert that into the list, and then we're going to produce the HTML page, which is the receipt for the subscription. Okay, and then finally, the last thing in this is just as server.http, which is just calls of a method that simply starts the water server. Okay, so let's get that running here. Okay, and so that was just, so in the graph, okay, there are two ways, but what it did was it just returned, so we just returned something that said that, okay, the server's been started, okay. There's two ways in which we can run the programming environment here. Here I'm just executing a piece of code, and then the result will be chucked into my browser. I also have another way of running the code, which is this is sort of more like a traditional Lisp environment where we have three panes here, and then one pane is the code pane, and then at and then this is sort of on the right here. We get, this is the representation in XML, so this is sort of the value returned by the code in XML, okay? And then this is sort of the browser, the stuff as it would be returned by the browser. So this is the value returned by the browser. That was for my slide thing, which was the last thing we looked at. Okay, so now let's go up to the browser here. And I'll say localhost. Okay, so that says, okay. So localhost means, give me the HTTP server that's running on my machine, and then just make a call to subscription form. Okay, so here's my subscription form. I'll say Henry Lieberman, and Lieber at, I hope I don't get any spam. I always seem to get a spam when I fill out a subscription form. So I'll say subscribe. Okay, Henry Lieberman is now subscribed. Okay. So let's just for fun, let's add another subscriber. So I'll say Earl Wagner, Wagner at media.mit.edu. Okay, Earl Wagner is now subscribed. Okay, now we're going to go back to our programming environment, and we look at the value of the variable subscribers. Okay, then we see that we have an object with two things in it. Okay, and we saw, I don't know if you can read that on the right, but this is the XML representation. It says a vector of two things. One is a subscriber whose full name is Henry Lieberman, and his address is lieber@media.mit, and so forth. And then another thing is a subscriber whose name is Earl Wagner. Again, if we go into the inspector, then here's that subscriber list, and then here's, so we have so here's the parent, and then there's it's a vector of two things, and then this is the email and full name of the subscriber. Okay. Again, this is not something that's very unusual as far as Lisp is concerned, but we can do it in the web environment. Okay. All right. So now I'll give you show you one other thing. And let's say so I'm just going to call this from the buffer here. I'll say subscribe Cindy Mason, and email address is radiodog@netscape.net. So just to, and let's select this piece of code, and now I'm just going to run the stepper. Oops. Oh, I'm sorry. I keep remembering the parentheses, Yeah. I'm not quite used to this yet. Okay, so here we're going to subscribers insert. So, evaluate subscribers. Okay, here's the insert expression. Okay, here now we're calling subscriber. The full name is Cindy Mason. The email is Rodeo Dog. Okay, then the whole thing returned a subscriber. Okay, and then we inserted it in the subscribers list and position 2, and then we're making a receipt. Okay, now we're stepping through the function receipt. Okay, and then we get Cindy Mason is now subscribed. Okay, and then the whole expression. And now if we look at the subscribers list, we should have 3 things in it. Okay, all right. So again, this is not very unusual from the Lisp standpoint. Okay, but what we've done here is give you the kind of interactivity that you're used to with Lisp. One of the things which I think is just really amazing about this is we can step through HTML even. We've never been able to step through HTML. No product on the market lets you step through HTML. But so we can, so it's just kind of, and we can step through stuff that's, will be running on the client or will be running on the server. We can give you an integrated environment that gives you all the kind of comforts that you're used to with Lisp, and then still keeps you within this kind of web and XML world. Okay. So that's the water programming language. So I just want to leave you with the idea that I think if we sharpen our parentheses a little bit, we can. We want to have a way of being able to bring these ideas to the web programming world. One of the other opportunities that I'd just like to mention is that there's a lot of excitement these days about the semantic web. Okay, and I've been involved. I'm a co-editor of a book that's coming out on the semantic web, and Tim Berners-Lee has been very much behind the semantic web. and I think you guys should also try to get behind that too. The idea of the semantic web, of course, is it's basically the web guys discovering knowledge representation, and we know. The idea that web pages should have explicit descriptions of knowledge that intelligent agents could then use for reasoning with, okay? So it's to be applauded, okay? And one thing we're thinking about this kind of environment, but if you look at the semantic web activities on the Web Consortium and stuff, nobody's ever addressed the question of how is it that users are actually going to deal with the semantic web stuff? How are they going to debug it? How are they going to write it? And so we think that things like this environments for this will be useful in doing the semantic web, which I think will really bring kind of AI ideas into the wider web world. I think things like CLHTTP and Blissful Allegro Serve will too. So I all encourage you to go, out there, write some web applications and try to get I think the web is, the big message is the wider, these kinds of things are ways to get the wider web world interested in some of the ideas that we're interested in. Okay, thank you. Yeah.
I like this stuff. I've already made this bet before. Other than the angle brackets instead of curly braces, what is it that will make this work better than curl?
He mentioned curl, and curl is sort of another thing which has kind of the similar goals, okay? And I think one of the differences between, I think actually this language design is better than the curl language design, but I think the important thing is that this is XML. Curl is not XML. Curl is just a way of putting code into web pages, but once you start doing the curl stuff, you're not in XML anymore. Curl is actually pretty pre-XML, I think, pretty much. So the curl data structures are not XML data structures. So I think the big thing is the quick answer is the integration with XML. Huh?
The syntax or the object system, what is XML in this definition that water is XML?
Well, the syntax, it looks the same, it talks the same, it quacks the same. We try to stay very close to making sure that we can do the standard XML stuff. Whereas in curl, like in the other languages, it requires a conversion step each time. Okay. Also, curl has a kind of an obnoxious business model. You have to install some piece of software on the machine, which then keeps the taxi meter running when you're running curl programs. No?
At one time.
Okay, that was my understanding.
For about 2 months, that was the model.
Oh, okay.
There were many other ones.
Yeah. But the big thing is the XML thing. Yeah. Okay. Anybody else? Yeah.
Do you implement macros?
No, there are currently no macros, but you could do it in a straightforward Lisp way. Yeah.
Actually, there sort of are. You can control the evaluate.
Oh, yes. We do have a thing called the eval kinds, which is basically, it's not quite macros, but, do you evaluate the arguments or not, And so that can be used to adopt the sort of macro programming style. But we could put in actual macros, that's not very difficult. Yeah.
One of your slides said, why not just program on the web in Lisp? And you said you should if you can.
Right.
And then I must have missed the middle part, because the next time I looked up, you were doing the XML stuff.
Yes.
So why can't you?
Well, you can, okay, and I think you should, But I think that if you want to integrate more with the XML world, if you want to convince your XML mad colleagues, okay, if you want to, it's basically integration with the other web things. Not that you can't do that in Lisp, because you can, but it'll always require some conversion step.
I think you said all those things, so I apologize. I just wanted to make clear that when do you think it's appropriate to just go ahead and use Lisp as opposed to?
Yeah. And also I think when you're starting, I think the big case also is when you're starting to put the programs in the web pages, so for political reasons or whatever, you don't really want to have Lisp sitting in the web pages. And even in I don't know actually. I guess I don't know of any way with, correct me if I'm wrong, those of you who are familiar with the software, but I don't know of any way in CLHTTP or in Allegro Serve to actually put a piece of Lisp in a web page and then have download to the client's machine enough of the Lisp interpreter so that they can be running the Lisp code sitting in the web page. Huh?
You mean client-side stuff?
Right. So we would do that with water. And it would be nice if they're in these systems if
So
there were a way
maybe
to do that.
Yeah.
Okay.
So client-side stuff.
Yes, all the way in back.
If water is going to do client-side programs, what's your security or sandbox and or authentication model?
Yes, there is a security model for water, and it's basically, I am not a security guy, so I'm kind of the wrong guy to ask about it, but basically what it's based on is the idea, it uses the object system for security, and what you do is you create these objects called views, and the view has a limited access to the underlying object, so it can kind of do all the security. But, I don't understand it, so I really can't. If you go to the site, there's papers that explain it, but I don't really have a good handle on it.
It's based on E rights.
Yeah.
It's based on E, I believe, E and E rights.
Oh, yeah, there was a language called E that had a security model, and I believe that security model is borrowed from E, but I don't really know the details. Is somebody else? Okay, thank you very much.